Somewhere in Italy, there is a building with no steel inside it, no rebar, no modern cement. Its roof is a single dome of concrete poured by hand almost 2,000 years ago, and it is still standing perfectly. Now look at a highway overpass built 40 years ago. It is crumbling. Crews are already tearing it down. So here is a strange question. How did people with no chemistry, no lab, no electricity build things that outlast everything we make today? Why does our concrete die in 50 years while theirs is still holding up a roof after 19 centuries? For a long time, we thought the Romans were just lucky. We were wrong. They were doing something we only understood a few years ago. And once you see it, you cannot unsee it. Start with the thing we got wrong. Modern concrete is the most used material on Earth. We pour enough of it every year to bury a city, and most of it is quietly failing. The problem is not the concrete itself. It is what we hide inside it. To make it strong, we run steel bars through the middle. Steel is tough, but steel has an enemy, water. Concrete looks solid. It is not. It is full of tiny pores. Water seeps in. It reaches the steel. The steel begins to rust. And here is the trap. Rust takes up more space than clean metal. So as it grows, it pushes outward. From the inside, the concrete cracks. The crack lets in more water. The water feeds more rust. The rust makes a bigger crack. Engineers have a name for this. They call it concrete cancer. Once it starts, it almost never stops. A bridge, a pier, a parking garage. The clock starts the day it is built. 50 years, maybe 100 if you are careful. Then it comes down. So we kept asking a simple question. If we are so advanced, why do the ruins last longer than the new build? To find the answer, you have to go back to the recipe, and the Roman recipe was strange. They took lime, they took volcanic ash, a specific ash from the ground near a town called Pozzolanic, close to Naples. They mixed it with rock and water. That was it. No steel, no factories. The volcanic ash was the trick. It was full of reactive minerals. When it met lime and water, it did not just dry, it reacted. It grew new minerals, locking the whole mass together like a stone that formed itself. A Roman writer named Pliny watched this happen and said something that sounded insane. He said their concrete, once set in the sea, became a single stone mass, impregnable to the waves, and every day stronger, stronger, in seawater. The one place our concrete dies fastest, theirs got tougher. For centuries, we read that line and assumed the old man was exaggerating. He was not exaggerating at all. Jump forward to 2017. A team of scientists gets their hands on cores drilled from ancient Roman seawalls, harbors that have been sitting in salt water for 2,000 years. They put the samples under powerful microscopes, and they see something no engineer would ever design on purpose. The seawater was not attacking the concrete, it was feeding it. Salt water had been soaking into those tiny cracks for 2,000 years and reacting with the leftover volcanic ash to grow brand new crystals. Rare, interlocking crystals right inside the gaps. Think about what that means. In our concrete, water finds a crack and starts the death spiral. In Roman concrete, water finds a crack and fills it with new stone. The exact same enemy, the opposite result. Every wave that hit that harbor was not wearing it down, it was making it stronger. The Romans built a material that used the ocean as a repair crew. But that still left one mystery. The crystals explain the harbors in the sea. What about the buildings on dry land? The domes, the walls, the ones with no seawater at all? Something else had to be going on. And in 2023, we finally caught it. For years, scientists had noticed tiny white lumps scattered through Roman concrete, little chunks of lime. Everyone assumed they were mistakes. Sloppy mixing, cheap materials, proof the Romans, for all their skill, just were not very careful. Then a team at MIT looked closer and realized the lumps were not a flaw. They were the whole point. Here is what they figured out. The Romans did not mix their lime gently with cool water the way a textbook would tell you to. They used quicklime, lime at its most raw and reactive, and mixed it hot, scorching hot. That violent heat baked those little white lumps right into the concrete, and each lump is a hidden reservoir, a tiny first aid kit waiting. Now watch what happens when a crack forms. The crack travels through the concrete, and it runs straight into one of those lumps because they are everywhere. Water gets in, the water hits the lump dissolves, flows into the crack, and hardens again into fresh mineral. The crack seals itself on its own with no one watching. The MIT team tested it. They made concrete the Roman way, cracked it on purpose, and ran water through the gap. Within 2 weeks, the crack had filled in and sealed shut. Then they made a modern version without the lumps. It just leaked forever. 2,000 years ago, without knowing a single word of chemistry, The Romans built concrete that heals its own wounds. So if their recipe is this good, here is the obvious question. Why do we ever stop using it? Why is the world built from the stuff that cracks instead? Two reasons, and the first one is speed. Roman concrete is slow. It takes its time to react, to grow, to reach full strength. That is fine if you are building a temple meant to stand for 1,000 years. It is useless if you need a bridge open by spring. Modern cement sets fast and hard. We traded lifespan for speed, and we did not even notice we were making the trade. The second reason is that we simply lost it. When Rome fell, the recipe scattered. The exact ash, the hot mixing, the feel of it in your hands, that knowledge lived in workers, not in books. So it faded. For over 1,000 years, nobody in Europe could pour concrete as good as a dead empire's. We had to reinvent the whole thing from scratch in the 1800s, and the version we reinvented was faster, cheaper, and far more fragile. We did not beat the Romans. We just found a shortcut and forgot there was ever a better road. Now for the part that actually matters, because this is not just a story about old buildings. Making modern cement is brutal on the planet. It takes enormous heat, and it releases an enormous amount of carbon. Cement alone is responsible for around 8% of all the carbon dioxide humans put into the air, more than every airplane on Earth combined. And then 50 years later, most of it cracks and we tear it down and pour it all over again. Roman concrete points at a different way. Concrete that mixes at lower heat. Concrete that lasts for centuries instead of decades. Concrete that heals itself so a crack is a scratch, not a death sentence. Right now, labs are racing to bring these ideas into the sea walls of the future. Walls that could shrug off rising oceans the way those harbors have for 2,000 years. The Romans could not tell you why any of it worked. They had no microscopes, no chemistry, no idea what a crystal even was. They just watched and remembered and trusted what the sea kept telling them. We have the microscopes now. We can finally read the recipe they left behind. The only question left is whether we are wise enough to use it. So the next time you pass a crumbling overpass, remember the dome in Italy with nothing inside it. 2,000 years of rain, earthquakes, and time, and it is still holding up the sky. They were not luckier than us. They were patient. And patience, it turns out, is the strongest material of all.